Alright, here's the next part. This is kind of cool. It's the first time I've ever done one of these outside in the rain before. It's kind of interesting. Okay, this is saying try to prove this. Well, true or false, really. Um, I'll do sort of a proof as to why this is. And, this is a lot of mumbo jumbo here. We have to worry about n being bigger than or equal to r plus 1. Well, in general, when we talk about NCR, n is always bigger than r, or at least, n is at least equal to r, because n is the number of things you're picking from, and r is how many of those you're going to pick. So, like, 10C10 makes sense. It's like saying I got 10 things to pick from, and I'm going to choose 10 of them. How many ways are there to take a sub-collection of 10 out of 10? Well, it's always 1. That's going to be the end of the Pascal's triangle row 10, which is kind of silly. So we're here just talking about not stuff like that. We're talking about stuff where n is at least greater than or equal to r plus 1. So, we could be talking about stuff like 10C9 or something more interesting. We're not going to choose just all of them, but at least slightly less than them. And basically what I'm saying here is that n minus 1 is greater than or equal to r. Okay, same thing as that. Okay, so in those types of situations, we're talking about stuff like 10C0 through 10C9. Do we have... Okay, you know what? Let's go to the 10 here. 10, and let's make one that's even more interesting than 9, because 9, that's kind of silly because we're just talking about, how many ways are there to pick 9 out of 10 is the same way as picking 1 out of 10. The one to exclude when you're choosing a group of 9 out of 10. There's 10 ways to do. So let's do one something like 10C7 just to make it slightly more generic and more interesting. They're saying, is that the same as 9C n minus r? Oh my gosh. 3 plus 9C r minus 1 should be 6. Is that the same as 9C3 plus 9C6? Well, let's think about that. This seems like a Pascal's triangle thing. Actually, in Pascal's triangle, that seems a little bit crazy, because in Pascal's triangle, the thing that's nice about Pascal's triangle, when you've got, those cells like this in one row, the next row is that one plus that one equals that one, and that one plus that one equals that one. So it's fun when we're talking about neighborly ones adding to the one below. But these aren't neighbors. 9C3, 9C6, those aren't neighbors. I actually know that 9C3 equals 9C6. That's always going to happen, because choosing 3 things out of 9 is the same thing as choosing 6 things out of 9, because choosing 3 to go on the trip out of 9 is the same number of ways you can choose the 6 people out of 9 who don't get to go on the trip, or 3 people get to go. Anyway, let's translate this into factorials and permutations and stuff and see what happens. 10C7, let me just rewrite the whole thing here. 10C7, I'm asking really, is that equal to 9C3 plus 9C6. Well, what is 10C7? That's 10P7 divided by 7 factorial. This is 9, this is 9P3 divided by 3 factorial plus 9P. You know what? I know these are equal. Let me just say this again. It's 9P3 divided by 3 factorial. I know those are the same. That's kind of nice. 9C6 equals 9C3. So let's just do that, because then I know I'm going to have common denominators and everybody's happy. Okay, so again, I'm asking, are these equal? I think I'm going to have to do number 16 on another page. Am I right? Alright, 10P7 is 10. It's the first 7 items of 10 factorial. 8, 7, that's 4, 5, 6, 7, divided by 7 factorial. Which of course is the same as 10C3, because a lot of this same stuff cancels out. This is here you go. Here's what it looks like 10C3. Because if I cancel out all the common stuff, it's 4. I'm gonna have this left on the bottom and this left on the top. That altogether equals 10 times 9 times 8 over 3 times 2 times 1. The 3 cancels with one of these. The 2 cancels with one of these. I really have 120. And on this side, still trying to find out, is that equal to 2 times this, because I have 2 of these, 9 for 3 over 3, 2, 1. which is cancel that. I got 3. It sounds familiar, doesn't it? Cancel that. I got 4. But see, I have this weird 7 here, and I don't have any factors of 7 over here. The 7's canceled. This is starting to look like it's not going to work. 2 times 3 times 4 times 7 is not the same as 3 times 4 times 10. So, no, I don't think it's going to be true. But let's figure out for sure. This is 28 times 6, which actually in general is 168. You know, so they write this big thing here and it makes it look like, oh, that looks really scientific and like, oh, like somebody knows what the heck they're talking about. No, they don't. It's 120 equals 168. The first time I find out, first example I try, here's your counterexample. No, this is false. All right. I decided to make a little in general sort of explanation of why, no, this in general isn't going to work. N minus 1 C n minus r plus n minus 1 C r minus 1 is always going to turn out to be 2 times this first thing. I mean, we're going to always have this issue of like NC3, and, or sorry, 9C3 and 9C6, which is going to be 2 times 9C3, which is never, you know, in general, not going to equal NCR. So same sort of thing is always going to happen. We have this 2 here times the first one. That doesn't always equal the original one we started with. So that took kind of a long time. Now let's talk about number 16. Is NCR is always going to equal NCN minus R. This looks a little more promising. Of course, it's one of those true-false. We got 2 questions. The first one was false, so what do you suppose is going to happen with the second one? Anyway, let's try real numbers again. Why not the 10 and the 7? Is that always going to equal 10 C, well, n minus r. If n is 10 and r is 7, n minus r is 3. Well, in Pascal's triangle, certainly this is always going to happen. This is that deal where you got the symmetry. The 7th thing in the row is going to equal the third thing in the row. We're talking about 10 things. Yeah, so this to me is way easier than the first one. If you're trying to decide, okay, 10, this would be 10p7 over 7 factorial. Is that really equal to... what am I missing on the first one? Why is that so much crazy harder than number 16? Okay, 10p3... Someone explain that one to me. Over 3 factorial. This is the first 7 items of 10 factorial. One, 2, 3, 4, 5, 6, 7 over 7 factorial. Wow, that takes a long time to write all that out. And the first 3 things, okay, is that equal to? First 3 things here. All right, well, guess what? This stuff cancels. 7, 6, 5, 4. And what I'm left with is, yes, the same thing as what's on this side. So, yes, that's equal. That's an easy proof. Now, I should say, actually, this is not really a proof. This is an example that 10C7 equals 10C3. But in general, is that actually true? Well, you don't have to prove it. You just have to say true or false. I mean, hopefully this is enough to convince you. If not, you could say, well, NCR in general, that's n factorial over n minus r factorial times r factorial. This one is NC n minus r, so this would be n factorial over, same sort of thing, n minus r. Oh my gosh. N minus r is like n minus n plus r with the n minus r in parentheses times the second thing factorial, which is n minus r factorial. Well, guess what? N minus r, here we go. This thing equals this thing, because it's the same thing. And really, new color, r factorial, wouldn't that be the same as this? If you think about it, n minus n is 0. We have r factorial there. So yes, these are actually the same thing. That's actually a lot quicker proof than investigating this example. But the example helps like show you that, yeah, it really actually works for real numbers. This one's a little bit shakier, I guess. All right, on to the next thing. The cost of maintaining a certain type of factory equipment has increased $120 each year. During the first year after the equipment was purchased, the maintenance cost was $1,400. What was the maintenance cost during the 8th year after the equipment was purchased? Well, this would be one of those things where it's an arithmetic sequence, right? I mean, we've got, let's write the first 2 terms out. It was $1,400 the first year. Then after that, it was $120 more. It's increased by $120 each year. It's been a constant increase of add 120. So it's plus 120, plus 120, plus 120. And that's the kind of thing we've been dealing with. Right? So there you go. Is this a 0? Sorry, pen. What was the maintenance cost during the 8th year? Okay. We're looking for A sub 8. Well, A sub n up here in general, if you look at your formula sheet, this is A sub 1 plus n minus 1 times d, where d is a constant difference, which is the 120 being added each year. N is the number of things we're looking for. Anyway, A sub 1 be the 1400. I mean, I'm going to say during the first year after the equipment was purchased, maintenance cost is 1400. That, to me, that means A sub 1 is 1400. Then we're going to add n minus 1. I was almost going to say 7. I'll say 8 minus 1, so you can look at this later. Times d. D is the constant thing that's being added each year. So that's like saying 1400 plus 7 times 120, which is like saying 2,240. Okay, part B. What was the total maintenance cost during the 8-year period after the equipment was purchased? So we're adding up all these, 1,400 plus 1,520 plus 1,640, blah, 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 and counting this one as the last one. So we're actually adding all of the first 8. Well, this is easier than some of the questions we've done before, because now by this time we've seen what the sequence looked like because of the way they asked the question. We've actually figured out that this is the 8th term, and the fact that it is the 8th term. Sometimes you've had to figure that out. So this is kind of nice now, actually, that they've asked it this way. Okay, this is in general n over 2 times 2 times A sub 1 plus, and then it starts looking at the rest of this, n minus 1 times d. And here we go. That's 4 times 2,800. I noticed people doing the, sort of their order of operations here wrong. I saw people putting like parentheses here and here and adding this 1,400 into all this other stuff and then doubling. That's not going to work. That is sort of an inappropriate way to do this. Plus 7 times 120. Didn't I just do so? Oh, I did, but I couldn't really see it. 7 times 120. Whoops. Calculator, please catch up with me. I should be able to do that in my head by now. 840. 840 plus 2,800 times 4. Great. 14,560. And that represents all the money that you paid over the entire 8 years, counting 1,400 plus 1,520 plus 1,640, etc. 8 of those added up as they increase gets us to 14,560. I'm guessing I'm not going to get through the next question by the time the 15 minutes is up, so I will pause this one for now. I'll see you next video.